Hi everyone, back with one more video. So what I want to do now is take some of the ideas that we've learned in the last two videos and put them together for one final application here. So all I have is a galvanometer, which we talked about during our last synchronous class, which was just the coil of wire in a magnetic field. When a current runs through it, it torques one way, or if you run the current the other direction, it'll torque the other way. And so this will measure whether there's any current flowing in this circuit. Here we have a solenoid, and all I'm going to be doing in this video is using a magnet to generate a current. So what we learned about in the induction video is that if I take the south end of a magnet and move it closer to here, initially there's no magnetic field inside this solenoid. When I bring this close, it generates a magnetic field that points towards the South Pole. So this way. The solenoid says, don't like that, don't want that magnetic field, tries to generate a magnetic field in the opposite direction. This coil goes around this way, so that means a current will run through this wire, and because there's so many coils and so many loops, it adds up to a fairly reasonably sized current, which you'll see on here. So when I bring this close, whoops, there we go, you can see the meter moves significantly just by bringing the magnet towards the solenoid. Now, you will notice that when I stick that in there and just let it sit, it goes back down to zero. And that's just because this wire has some resistance. It's not a perfect conductor. If this somehow we had a superconducting wire, as I brought this close, the current would start flowing and it would continue flowing, but because of some resistance, eventually that current will drop back down to zero. Now you'll notice when I remove the magnet, this flips the other way, and that's really the same thing. When this is in here, right now, there's a magnetic field this way inside the solenoid. When I remove it, there's now no magnetic field. The solenoid says, oh, we had a magnetic field and you changed that. I don't like it. There's now no magnetic field. It tries to make a magnetic field that will restore the previous magnetic field. So in this case, it needs a current flowing this way, which is the opposite way of when we stuck the magnet in. So once again, you take the South Pole, you put it in, generates a current. When I remove it, generates a current in the opposite direction. You'll also see that if I take this magnet, just turn it around so the north side is there. When I stick it into the solenoid now, this time we're going to get a current in the opposite direction, and when I remove it, back this way. Of course, I can do the same thing on the other side as much as I want, and if I take more than one magnet, it just starts moving a lot more. So the stronger the magnetic field, the higher the current. So this is kind of one application where having a magnet, I can generate an electric current. And you can maybe see some applications to this, although the details will be a little bit fuzzy. If I can just move magnets, if I can physically move a magnet and generate a current, that means that all I need is a way to move a piece of metal, say spin a piece of metal. And if I can spin a piece of metal, I can change the magnetic fields and I can generate current. And this is the basis for how we actually generate power in our day-to-day lives. There's either a dam or a coal plant or something that heats water up, spins a fan, that fan has moving magnets on it, and because it can change a magnetic field constantly, that generates an electric current in a set of solenoids, and that is the power that we use in our house today. So that is an application for the induction stuff we've been learning. We'll learn a little bit more about that in the next couple of weeks and some applications, and we'll learn how generators work, and we'll learn about the drawbacks of generators. But for now, I just wanted to show you that quick example. That's it for now. Thanks, guys.